2, 1. 3, 2, 1. Have you ever wondered how much battery draw your phone has on your EV battery? Let's figure it out. So today I'm going to be specifically talking about the Tesla Model 3 Standard Range Plus 2019 compared to the Samsung Galaxy S10 Plus, also from 2019. I've always been a little interested in just how much battery draw it takes charging up any of my peripherals, laptops, phones, multiple phones. So I decided to dig into it and just see what kind of effect the battery draw has. The Tesla Model 3 is a 350 volt system, has a 50 kilowatt hour battery pack, which is the same as 50,000 watt hours, and it's 250 watt hours per mile is the average range that I've been getting on my car in the last couple thousand miles. Over here on the Samsung side, we have the Galaxy S10 Plus. It's a 3.6 volt system, and it has a 4100 milliamp hour battery. Now, before we can start comparing these side by side, we need to get them in the same unit. Amp hour, kilowatt hour, or watt hour, they're not the same thing. A more accurate battery capacity rating is actually the watt hour, because it doesn't take into account the voltage of the system, whereas the amp hour takes into account the voltage of the system. So because these are drastically different voltage systems, we're going to want to get everything into watt hours. So we need to convert the milliamp hour battery of 4100 milliamp hours. We need to convert that to watt hours. The equation to convert amp hours to watt hours is amp hours multiplied by the voltage equals watt hours. We have 4100 milliamp hours, which is, we need it in amp hours, so that's 4.1 amp hours. We need to multiply that by 3.6 volts, and we're going to equal roughly 14.8. So the 4100 milliamp hour battery rating of the Samsung Galaxy S10 is equivalent to 14.8 watt hours. So now we got the 50,000 watt hours of the Tesla, the 14.8 watt hours of the Samsung. First thing you'll notice right off the bat is just how much bigger the battery on the Tesla is compared to the phone. Now, of course, we know that the battery on the Tesla is huge and the phone is small, but if you look at these two numbers, you can clearly see that it might be a lot larger than you realized. Maybe not, maybe you knew that. To me, this number was kind of staggering, because what this equals, if we take the 50,000 and divide that by 14.8, you get over 3,300 times, which really means you could charge your phone 3,378 times from 0% all the way to 100% on the battery pack from the Tesla Model 3. So I really want to see what kind of effect charging my phone has on my overall battery usage. So I think one good way to look at this is how many times would I have to charge the phone to see a 1% drop on the battery. So let's do that right now. 1% on a 50 kilowatt hour battery pack should pretty much be 2 kilowatt hours. So if we take 2 kilowatts, which is 2,000 watts, and divide that by our 14.8, so that's 1% of battery usage, and we're dividing how many times our phone can charge with 1%. That's going to equal roughly 135. So you could charge the Samsung Galaxy S10, which is the larger of the phones, 135 times to see 1% of battery drop on your Tesla Model 3. So I think we're getting to the conclusion that it probably doesn't really matter whether you plug your phone in or not. Kind of like in a gas car, you don't really think about it, but you usually don't think of it because the battery's always being charged. However, the draw of a phone is so small, it shouldn't really be something you think about at all. Alright, so how much battery does it take to just charge your phone once? What if your phone is completely dead and you want to charge it to 100% while you're cruising? How much battery is it going to take to just charge your phone once? The way I figure these problems out is I take the 135 charges per 1%, right? And then I think if we were to make one charge out of what percent? So you got your 130, you cross multiply your 135x. Your 135x equals 1. Divide by 135. And you're going to get a 0.007, roughly. So to charge your phone from dead to 100% full, it's going to use 0.007% of your battery. It's pretty much not even a noticeable amount. So let's convert that into miles. How many miles do you lose by charging your phone from dead zero to 100%? So if we want to figure that out, we know that's going to depend on your driving and how efficient your vehicle is, but based on my average of 250 watt hours per mile, we can figure out how many miles I'm going to lose every time I charge my phone from 0 to 100%. So we're pretty much just going to take the 250 watt hours and simply divide that by how much watt hours we use to charge up the phone. And that equals roughly 16.8. So what that really means is I can charge my phone 16.8 times with the amount of energy it takes to travel 1 mile. So without really getting too deep into the math, if we can charge something 16 times to get 1 mile, we can obviously say, well, to charge it once would be to get 1/16 of a mile, right? So knowing that, we could pretty much say that you're going to lose about a 1/16 of a mile of charge every time you charge your phone from 0 to 100%, roughly. So if you run the math on like 5,200 feet, which is about a mile, and you divide that by 16, you're going to get 325 feet. So, in my case, using my phone, my car, my driving habits, I can charge my phone from 0 to 100% in about the same amount of energy, battery usage, that would get me 325 feet in my car. That's about a football field. So what I take away from this experiment is it almost has no effect at all on your car, whether you're charging your phone or not. And I would even argue that you could charge your phone, you could have your wife plug in her phone, and the kids in the back could plug in their phones, and even timesing these numbers by 4, you're still not in trouble, right? We times 300 by 4, right? We're getting to the 1,300 feet range. So on a trip, if you were to charge your phone, your wife's phone, and 2 of your kids' phones, all the way from dead, all the way to 100%, it's only going to affect you by like 1,500 feet total. So I think it's pretty safe to say plug in your phone, don't worry about it. Plug in your laptops, plug in your tablets, enjoy the car. It's not going to make a difference. Well, I hope this helped some people out. It was definitely a little eye-opening for me. And there's a good chance there's some incorrect information here. This is something I just scribbled together real quick. So feel free to correct me in the comments if I'm way off, and maybe I am. And of course, if you're off up here, then it's just going to screw everything up on the way down. But I think this is pretty accurate. So, all right, have a good one, guys.